Hi, my name is Peyton Crenshaw, and this is my lab for oscillations. So, the primary goal of this lab was to investigate the motion of a mass spring system that simultaneously swings like a pendulum and oscillates along its length. This was achieved by systematically comparing the position data gathered from a physical experimental model with the predictive outcomes generated by a computational model. Doing both of those, we used Tracker and GlowScript. The primary physics concepts during this lab were Newton's second law, which is the acceleration of an object is directly proportional to the net force acting on an object and inversely proportional to the mass. And then also using the energy principle, which is a system's total energy changes by the exact amount of work done on it by its surroundings plus the heat transferred to it. This is a direct result of the principle that energy can't be created or destroyed, only moved or changed in form. These are some of the fundamental principles and models. So I have the position update formula, the energy principle, the velocity update formula, the kinetic energy formula, Hooke's law, which is spring force, and Newton's second law. And then here are some more, such as spring potential, gravitational potential principle, and then net force. And then in this lab, the system is identified as the spring, earth, and the block, and then the surroundings is none. And then just to give an overview of the results through this lab, I learned that there was a change in that the change in energy in total is always zero. So here's my tracker using the video that we were given from the lab. And then here's just an overview of my GlowScript code using some of the constants that we were given and some of the equations that I showed before. Here are my graphs that I got from GlowScript as well on the left. And then when we want to talk about what does it mean, the first question, which was for your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. And yes, it is satisfied. The sum of all the energy is zero. Based on the principle, the energy cannot be altered and must stay the same. This is justified by the behavior of the energy plots, which show that the change in total energy is accounted for. The kinetic energy and potential energy balance each other out at all times, since energy cannot be created nor destroyed. For the next question, using the data you obtained in Tracker, make two separate estimates of oscillation periods. First, by estimating the period of oscillation from the x position data, and second, by estimating the period of oscillation from the y position data. Compare the two estimates and discuss. So I used the graph on the left to create this one, and my oscillation period for the x position was 1.617 seconds, and my oscillation period for the y position was 1.523 seconds. So in all labs that have humans, you have to account for human error. And in this experiment, we can also account for drag. Both of these factors can cause issues in an experiment and cause inaccuracies. And to conclude this lab, the complex motion of a mass spring system that simultaneously springs and oscillates was successfully investigated, and we saw that the answer is zero.